Welcome, this is 5.3 Graphing from Vertex and Intercept Forms. All right, so in the last time we learned like the basics of graphing. So if I gave you the vertex, you could find the A value and use that to find the growth pattern, right? So again, we talked about like 1A, 3A, 5A. So if we plot the vertex, then we would just go over 1, up 1A, over 1, up 3A, over 1, up 5A. Or if A was negative, then we would go down, over 1, down 1A, like that. So what information do you need in order to graph a quadratic function? Again, so this is just kind of going to pound this into your memory. Okay, you always need to find the vertex and the growth pattern, or you could find the A value, which tells you the growth pattern, A value. Okay. So our first form, we're going to have three forms we're going to talk about. Today we're going to talk about vertex form and intercept form. So the vertex form is my favorite. Okay, it's the easiest to graph from because you can find your vertex really easy from vertex form. Okay, perhaps that's why it's called vertex form. So the equation or the form for vertex form is y is equal to a times x minus h squared plus k. Okay, where h and k is your vertex. All right. So one thing you should notice that when you are trying to find the vertex from vertex form, when you take it outside of the parenthesis, it's going to change its sign. Or I've also heard that some people say that x's tell lies. Okay, so if that helps, whenever you take something out of a parenthesis, whether it be vertex form or our next method or next form, which is the intercept form, whenever we take it out, it's going to be opposite of what you would think. It'll be the opposite of what's inside that parenthesis. Okay, and we'll do some examples of that. Okay, so we can easily find the vertex from vertex form. We can also find the axis of symmetry because the axis of symmetry, x equals whatever that value is always the x value for your vertex. Okay, so here the vertex here would be x equals h, and again it'll be the opposite sign of what you would think it would be. So just keep that in mind. The direction of opening is always easy to find. It's always going to have to do with A. So if A is positive, or maybe we should say it the opposite direction, the direction of opening is up if A is positive. Okay, kind of think about that being happy. If you're feeling positive, then it's concave, or it opens up. And then it's down if A is, and when I'm talking about A is this leading coefficient, okay? A is negative. So you'd be kind of like sad, okay? Concave down, or facing down. Direction of opening is down. All right, so those are kind of those key features we can find really easy. Vertex, axis of symmetry, and the direction of opening. All right, so let's do some problems real quick. Feel free to pause whenever you'd like to practice. Okay, so of course we want to find the vertex and the A value. So here, again, when we take something out, this would be like our H and our K, and when we take it out, it's going to change its sign. So we'd get -2, comma, -1. Okay, so when we take it out, it's going to change its sign. So we'd plot that point, -2, -1, and then we need to find the growth pattern. So what would A be? A, again, is our leading coefficient. Here, it's just a 1. So we'd do 1A, 3A, 5A, and A is 1, so we'd just do 1, 3, 5. We'd go over 1, up 1, over 1, up 3, over 1, up 5. and then we do it on the opposite side. Connect those dots, and we're done. Super easy because we can find the vertex really easy. Okay, look at B. We want to find our vertex. So what would be our H? What would be our K? Okay, so usually when we have it in vertex form, we have some sort of parenthesis, and what's inside would be our vertex. So if there's no parenthesis, then what does A or H have to be? Okay, so it would have to be something like x plus 0. Something like that would make it look like our vertex form. So if something's missing, it will always be a 0. So here our H is missing, so it'll be 0, and our K would be 4. So we can plot that 0, 4, and then we'd want to find our A value. Again, it's our leading coefficient, so that would be 1. And we'd use the same 1A, 3A, 5A. So we'd go over 1, up 1, over 1, up 3, until we're outside of our graph. Okay, again, you're required to do 5 points, so that is good enough. All right, C, so here what would be our vertex? So again, if something's missing, it's going to be a 0. So this would be something like plus 0 would be our K. So here's our H, and K would be, when we take it out, it changes its sign, 2, 0. And then our A value would be 1. So it would go 1A over 1, up 1A, which is just 1, then 3, and then 5. Okay. And we've got it. All right, so if you would pause and see if you can do these other two, and also use example 1C to find those key features. All right, so here we'd find our vertex is, again, it's the opposite of what's inside the parentheses, so it'd be 1, 2. So 1, 2 is right here. And then our A value is a -2, so we'd do 1A, 3A, 5A. That would give us a -2, a -6, and a -10. So we'll go over 1, down 2, over 1, down 6, and that will get you all the way out of the graph. Okay, and let's do one more. So here we want to find our vertex. Again, what's inside is opposite of what you'd think, so it would give us a -4, 3. So -4, 3. And then our A value here is a -3. So we'd do 1A would give us a -3, would go over 1, down 3. And then 3A would give us a -9, and that would give you all the way out. Sorry, I need to adjust this next time so it's all within the graph. Okay? All right, so let's talk about key features. So hopefully you gave this a try, so I could see that a little better. So we look at this graph, and we want to find the x-intercepts. So here there's 1. It would be 2, 0. That's from here. Y-intercept is 0, 4. Axis of symmetry is x equals 2. The vertex is 2, 0. It's also the x-intercept. Is the maximum, or is the vertex a maximum or a minimum? It's a minimum. And its value would be 0. The domain is all real numbers, or we could write it like this, or like this. And then the range would say all y values. So it would start at 0, and then it would go up. So we'd go from starting at 0 and goes to infinity. Again, we use a bracket because that value is a point. It's part of it. Okay, you could also write it as all y values greater than or equal to 0. Increasing, so again, when the rate of change is increasing, so it would be everything on the right side of the vertex. So starting at 2 all the way to infinity, or you could say all x values greater than 2. And then decreasing would be from negative infinity to 2, or all x values less than 2. And then the direction of opening is up. All right, so that is vertex form. So again, we just want to find the vertex. Again, what's inside the parenthesis, when you take that h out, it's going to be the opposite of what you would think. Okay. Intercept form. This is also called factored form. Okay. Because the form of that is y equals a times x minus p and x minus q. Okay, and this looks like where we do like glasses and we end up getting 2 parentheses, okay? And that's really what we'll do when we try and switch forms in a minute or later. So the second method to graph is the quadratic, for a quadratic function, is to use intercept form. This form is beneficial because once a quadratic is in intercept form, you can easily find the x-intercepts. Okay, and again, we talked about in 5.1 where the solutions of a quadratic are the x-intercepts. Okay, and in the past we were able to, like when we solved by factoring, is we would say, well, either x minus p is equal to 0, and we would add p to both sides. So one of our solutions, or one of our x-intercepts, would be p. And then we would do the same for the other parenthesis, would say either, or this is x minus q is equal to 0, and we would add q to both sides, and we'd say that x is q. So the x-intercepts are the solutions of p comma q. All right, so again, easy to find key features. So is the x-intercepts, that would be p comma 0 and q comma 0, if we write it as an ordered pair. Okay, axis of symmetry. So the axis of symmetry is always going to be halfway between p and q. Between p and q. Okay, because we know that parabolas are symmetric, so the axis of symmetry has to be right between those 2 points. And then the direction of opening is the same as what we said before. It is up if a is positive, like happy, and down if a is negative, sad. Okay. All right, so let's do a problem together, how to find the vertex. Because again, that's what we're trying to find for all of these, is to find the vertex and the a value so that we can use the growth pattern. So the first thing that we're going to do is we're going to find or locate and then plot the x-intercepts. Okay, so for this example, if we want to find our x-intercepts, again, when you take something out, it's going to be the opposite sign, just like we did with vertex form. So our x-intercepts are going to be 4 comma 0, and then from here we'd get negative 2 comma 0. So these would be our x-intercepts. We can plot those. One's right here and the other's right here. Okay. Next, we will want to find the axis of symmetry by going halfway between the x-intercepts. Okay, so we would look at these 2 points and say what's right in the middle would be this, would be our axis of symmetry, would be x would be equal to 1. Okay, so now we have our axis of symmetry. And then the last thing we would need to do to find the vertex is to find the y value, because we know that the vertex is on the axis of symmetry. We just need to find the y value that goes with it. Okay, so if you kind of recall, if we went all the way back to here, if we have an x and want to find a y, all we need to do is to substitute it into our equation. Okay, so we will plug the axis of symmetry into the equation to get the y of the vertex. Okay, so we have our axis of symmetry. We're going to plug that into our equation. And our equation was y is equal to x minus 4. So x is 1. We're going to plug that in. And then we'll do x plus 2. And x is 1. So we'll do 1 plus 2. And then we'll just simplify it. So y is equal to 1 minus 4. That gives you a negative 3. And 1 plus 2 is 3. So we'd get y is equal to negative 9. So this would be our vertex. Our vertex is 1 comma negative 9. Okay, so we can plot that. This is outside, I'm sorry, so we'll put it right here. And then we're going to use our growth pattern. So a here, again, it's the leading coefficient. A here is 1. So we'll do 1a, 3a, 5a. So we go over 1, up 1, over 1, up 3, over 1, up 5. And that's nice, that matched. And then we'll connect the dots. Sorry, that's not a very good parabola, but that's good enough. All right, so let's practice a couple together, and then you can try by yourself, and we'll be done. All right, so again, we want to find our x-intercepts, and it's the opposite of what you'd think. So here we have our x-intercepts are going to be a negative 2, 0, and a negative 6, 0. We want to find the axis of symmetry, which I kind of like this one. We'll do it halfway between the 2 points. So our axis of symmetry is negative 4, and then we're going to plug that in to our axis, or into our equation. Let me just remove down here. So we'll have y is equal to negative 4 plus 2 and negative 4 plus 6. And we'll just simplify it. You could just put it all in your calculator too, but we'd end up getting negative 2 and 2, or negative 4. So our vertex here is, it was what, negative 4, negative 4. So we'll plot that point. Oops, we'll do red. Okay, and then we just use our growth pattern to find more points. So here again, A is 1. So we'll do 1A, 3A, 5A. We'll go over 1, up 1, over 1, up 3, over 1, up 5. And then we're done. Sorry, it's a little messy, I'm sorry. I'm trying to make it so your videos aren't super long. So I try and go a little quicker. And I lose some of my awesomeness of not being messy. All right, so if you would give B and C a try. Okay. And again, you can kind of think about like our solutions, trying to solve to find solutions. So B is one that I feel like some students struggle with to figure out what the solutions are. But again, we are going to set this equal to 0 and solve, and we'll set this equal to 0 and solve. So one of our solutions here is going to be 0, and the other will be 4. So our x-intercepts will be 0, 0, and 4, 0. Again, it's the opposite of what you think. When you take things out of parentheses, it will change its sign. So we have 0 and 4. Our axis of symmetry is halfway between, so we have x equals 2. And then, axis of symmetry, x equals 2. And then we want to find our y value. So we just plug x equals 2 in, would have 2 times 2 times 2 minus 4. So this would give us 4 times -2, or a -8. So our vertex will be 2, -8. So 2, -8 was right here. And then we'll use our growth pattern. So here A is 2. Our leading coefficient here is 2. So we'll do 1A, 3A, 5A. And 1 times 2 is 2. 3 times 2 is 6. And 5 times 2 is 10. So we'd go over 1 up 2. And then we'd go over 1 up 6. And we already have that point there, so that's great. And then we'd go over 1 up 10. And that would be outside of our graph. So connect those dots. And you're done. All right, last one. Again, we want to find our x-intercepts. So again, it's opposite of what you'd think. We have, when we come it out, it'll give us a +1 and a -3. Okay, so we would plot those. Axis of symmetry is halfway between. So axis of symmetry, I'll do it over here. X is equal to -1, so be the axis of symmetry. And then to find our y value for our vertex, we plug x into our equation. So, sorry, I'm trying to see this, would get negative. In our parentheses, we would do -1 minus 1 and -1 plus 3. So we'd get negative, and this would get a -2, and this would give us a +2, and we'd end up getting 8. Sorry, 4. Gosh. 4. So our vertex would be -1, 4. So let's plot that. -1, 4. And then A is a negative, I'll do it here, A is equal to a -1. So we'd do 1A, 3A, 5A, so we'd go over 1, down 1, over 1, down 3, over 1, down 5, in both sides. And we're done. All right, well, if you have any questions, please feel free to email me or give me a call. And we'll see you later.